Good morning, everyone. I'm so pleased to be with you here today. This is very hot topic that we'll be discussing over the next 50 minutes, and thank you for joining. So today's topic is about AI-powered supply chains. So on a personal note, these are two topics that I personally very fond of, both AI and supply chain. So it's with a great pleasure that I will be discussing with you here today how these two concepts actually intertwine, having as a backdrop how actually AI can help us to mitigate, risks in the global economy, knowing that, of course, supply chains are more and more intertwined, are more and more linked, more and more flows across countries that make that these risks, especially global risks, are particularly of concern for most of you, I guess, that are listening to us. So this is a joint work between LTP and 83, and we'll have with us, I'll tell you in a while, but both Maurice and Vinayak to discuss actually these topics over here. So let me tell you that today we have a packed agenda. After my welcome, the idea is that we'll go through what is the state of the art in supply chain optimization and what might be some of the drawbacks on how we have been optimizing our supply chains right now. And the focus of today, as I said right at the beginning, is about the surge of supply chain disruption. So we know that disruptions are getting more and more frequent, and this demands maybe different ways to look at it. And what we'll be discussing then is how leading companies are actually able to adapt and to make sure that these disruptions are tackled in the best way possible. So we'll use a couple of examples to guide you through real world examples in which we have actually showed that different and more appropriate methodologies can actually lead into enhanced results when it concerns to dealing with these disruptions. So then Vinayak will actually deep dive on that, and we'll discuss a little bit more how we can really create resilient supply chains. And we have seen by the recent news how important there is, being it tariffs that the US have been discussing recently. We have just seen what happened in Syria this week. So clearly, I guess we have a good forecasting of what of the timing of this webinar, and I hope you find it the same. So let me just first telling you that besides me, as I told you, there will be Maurice and Vinayak. Both Maurice and Vinayak are the co-founders of 83. 83 is a company that has been really, at the core of this interception of, AI and supply chain. So I'm really proud and happy of being with Maurice and Vinayak discussing these topics here with you today. And of course, both Maurice and Vinayak are also, professors at Wharton and at University of North Carolina, Chapel Hill. Myself, Pedro Mourinho, I should have introduced myself better. So I'm also a partner, but at this time at LTP Labs and professor at the University of Porto. And I guess the three of us, we share a deep interest in both these topics and in particular the intersection of these topics of AI and supply chains. So we want this to be as dynamic as possible. So please feel free to jump in the Q&A of this webinar. You can do that by actually typing on this button and clicking on this button and typing your questions. We'll be gathering all your concerns, doubts, comments, and we'll make sure that towards the end of today's event, we'll have time to go through them. So once again, bring your doubts. This is for you. So make sure that you kind of post here whatever comment or question you may have. Very good. So let me just start by, warming up a little bit the session for today. And I'll gloss over some of the key concepts that then Maurice and Vinayak will actually deep dive. And on the backdrop of what we'll be discussing today, I think it's important to understand that despite all these concerns, and I just started to discuss the US and the Syria events that took place recently, the truth is that the projected change in trade is still positive. So what we project for the next years is that trade will continue to evolve. So both importations and exportations will continue to grow. And overall, we're talking about more than $33 trillion to be, traded this year. So, of course, it doesn't mean that all flows are positive. For sure, between US and China, things have calmed down a bit. For sure, all the transactions with Russia have also not being at the same pace. But there are other flows that have actually increased more than these downflows to actually, rebalance the whole trade. So, for example, between the European Union and the US, clearly there's been an increase on this trade, and that is of note. And notice that this is not something only over the last year or just from this year to today. This has been something that has been increasing since the 60s. So around the 60s, we start tracking this trade openness index. This is basically an index that the World Bank tracks, which basically divides all the imports and exports by the GDP of a given region. And what we have seen is that the share of imports and exports have been increasing over time when compared to GDP, basically all over the world. European Union is probably where we, by also how we are configured, that's how we even see a larger share, actually a share that is higher than 100% in recent years. But overall, and the world line, the one in purple, shows that we see this interconnectivity growing year by year, with some bumps and dumps, of course. And this has to do with a lot of things, right? Of course, access to global markets and all the trade agreements that have been crafted along these years has helped with that. Different parts of the globe have different specialities, and we have been, able to leverage these specialities. Of course, there is also economies of scale. There is the opportunity also to tap into, pockets of innovation that have been sparked in different places of the world, and use this innovation to infuse different concepts, different products, different services into our supply chain. And of course, this allows also companies to diversify their risk by tapping in different markets besides their domestic market. So all in all, despite all these bumps that for sure have been in top of our mind recently, I want to give you the message that, we have been more and more intertwined. But of course, all this net that is being, so closely knitted, sometimes has, we have seen some holes, and some holes that we were not expecting. Some we were expecting, some we were not expecting. But the common denominator between these different events is that they really, upset, they really disturbed, they really disrupted the supply chains. Of course, we'll still to see what is going on with Trump presidency now going forward, and the tariffs that are supposed to be, raised for different countries. But, the nature of these disruptions can come from very different reasons, not only geopolitical, but for example, the recent disruption, or the more or less recent disruption that we had on the Suez Canal, is also another great example of, the unknowns that are out there and that really play some heavy tolls in our supply chain. So how do we deal with that? That's really tricky, but I guess we all could agree that forecasting these can be really hard, right? The error of forecasting these types of events is just too large, and if we trust on, experts' judgment, well, we might get really biased, I guess. There's also, and underlying this, of course, this is a very unpredictable event. And what we conjecture is that the traditional models really have some inflexibility issues that are at the core of how we have been planning our supply chain. So this traditional paradigm of forecasting and planning might not be really the best way to go forward in these very turbulent events and or turbulent times. And that's what we really want to explore with you today. And I think that's where AI really comes into play, because either through, the fact that through AI we can chew much more, data that can allow us to understand what goes on in the different echelons of our supply chain. So this idea of end-to-end visibility that clearly has already penetrated in a lot of different industries and allow us to really have a closer gap between planning and acting is one of the things that we want to distill in the next minutes. There's also, of course, the effectiveness of the decision making. So by using this data, but more interestingly, by connecting the data to the dynamics of the supply chain, can we really adapt and act more efficiently and more effectively to what's going on today, but more interestingly, maybe tomorrow? And all of that also ties to agility. Agility is a word that I guess we will use a lot of times here today, but how can we actually be more agile in the way we take decisions over the supply chain once a disruption occurred through the use of AI? So this will be at the core of what we'll be discussing, but this was just a teaser. And for that, I actually want to invite Morris to come over, and I guess he will get us a much more, detailed overview of these different concepts, both in terms of disruptions and also how to deal with these disruptions. Morris, thank you so much for joining, and the floor is yours.
Okay, thank you, Pedro, for that great introduction and to our topic of today. And I'm very excited to be able to be here to join all of you. So as Pedro mentioned, what I want to do in this next section is to dig a little deeper into the challenges that are facing supply chain today in terms of the disruptions. And I go to the next slide. Just 1 second. There we go. So as Pedro mentioned, at the heart of what is concerning supply chain managers these days is the fact that these levels, these risk events, these disruptions are increasing in frequency, and they're also increasing in severity. But let's dig down a little deeper. We can identify 2 classes of disruption. One of the common ones that everyone knows about, natural disasters like earthquakes and hurricanes, the pandemic and the epidemics that we've seen recently, the disruptions to the logistic network or to suppliers, as Pedro mentioned, the recent blockage of the Suez Canal. And of course, everyone is aware of the chip shortage that occurred during the pandemic. There was also other things like toilet paper shortage. So we've all experienced in that. And at the market side, demand increases. All of these things are the normal disruptions that supply chains are designed to help us mitigate. However, there's also another class of disruptions which we label as geopolitical. These are disruptions that are caused by the decisions made by various entities. It could be a government, it could be your competitor, it could be other groups of individuals. And so, recently with the U.S. election, we now understand that there's going to be more tariffs and restrictions on trade into the U.S. We don't know exactly what's going to happen. There's been all kinds of conflicts, the Ukraine, the Middle East, Syria, all of these things. And of course, the government can change policy in reaction to these things, changing taxation, import sanctions, all kinds of things. So these are the kinds of risks and disruptions that managers have to face in today's world. We can classify them into 2 types. One we sometimes call a black swan. A black swan, is something that you never see. It's an event that none of us have probably ever seen. But we know, these events can occur and they can be very impactful. Another class of events we sometimes call white rhinoceroses, white rhinos, like, for example, China invading Taiwan. So these are highly probable. They could occur. We don't know when they will occur or if they will occur, but we can expect them to. And of course, they also have a high impact. The bottom line here is, as noted earlier, it's impossible to predict either black swans or white rhinos without a significant error. However, managers can imagine the future. We may not be able to predict when these things will happen, but we certainly can understand and imagine that they may happen. And if they should happen, the consequences could be quite severe. So how do we proceed from that? there are three metrics that are often used to describe how supply chains can or should respond. The first one is efficiency, which we define as the optimal allocation of resources in the end-to-end global supply chain. This is what has been driving supply chain planning as we saw the surge in global trade, the connectiveness of across country borders, and many companies now have done a very good job of honing the efficiency of their supply chain. However, supply chains have to respond to these events quickly. And so that we label the ability to respond rapidly in a cost-effective way as agility. These are the short-term changes. This is what we saw during the pandemic, for example. Resilience is associated with a longer-term adaptation to structural changes. And these adaptations could involve modifying supply chain strategies, or it could be introducing new products and new technologies. The bottom line is, how do we, as companies, as managers, as government agencies, how do we respond to these challenges? How do we achieve efficiency, agility, and resilience? So that's pretty much where we want to go with this seminar. As Pedro mentioned, the AI intersection with supply chain planning, which is what we're going to talk about, can yield a variety of benefits. For example, it allows you to have end-to-end visibility, in which case you could build models for machine learning to directly link supply chain decisions to the data. That's the key. So data-driven decisions. So we're not talking about getting a better forecast. We're talking about using the data in an intelligent way to make better decisions. So those better decisions have to involve the fact that we can't predict these scenarios, but as I said, we can imagine them. And therefore, we can evaluate strategies and plans for these future scenarios. All of this requires deep domain knowledge. And so senior supply chain function managers and those in the company with analytical skills, the data scientists, the operations analysts, all have to work together to help support this process of effective decision-making. And then finally, we have the fact that using AI and machine learning allows us to respond more quickly and in a more coordinated way. And we talk about a granular digital twin, which is a representation, a digital representation of the supply chain. And its goal, its purpose, is to capture the interaction between decisions, data inputs, and performance outputs. So that's the key. How do we do that? All right. So let's now turn to the next section of this event. And I would like to introduce my colleague, Vinayak Deshpande, who is a professor at the University of North Carolina in the Ken Flegler Business School. And he's also a co-founder with me of the company AD3, which is a company we started several years ago with the sole purpose of applying AI and machine learning to support and improve and enhance supply chain planning. So let's proceed. Okay, so
let me talk a little bit about some of the case studies where we have implemented AI and machine learning. So first of all, let me take the opportunity to thank you all for attending. This is exciting to be here to talk about AI and supply chain planning in more depth. Our first case study is from the semiconductor industry. And in the semiconductor industry, there are a lot of different challenges this industry has faced recently. And I'm going to talk about a situation. Actually, Morris is back here, so he can talk and describe this industry a little bit more. And
okay. Yeah, I have returned. Thank you. Yes. So the first example that we want to talk about is taken from the industry, the semiconductor industry, in particular, the companies that manufacture the equipment that's used in fabs to produce the chips that have become so essential to every product in every aspect of our life. And so we have worked extensively with one of the leading equipment suppliers of semiconductor equipment and looked at their supply chain. They operate a supply chain to support what is called the installed base of equipment. Those are copies of the equipment that customers have purchased, have installed in their fabs and their factories, and are dependent upon those that equipment in operating, or otherwise the process is down. And this is a very costly and expensive thing if there's a disruption to the supply chain. Years ago, I worked with Intel, and I remember in a meeting where they had their equipment suppliers present, I was able to listen in, and they told these suppliers, if one of your machines fails in one of our fabs, you have 15 minutes to respond with the right part and the customer engineer to repair it. Because the cost of a downtime, for even years ago was a multi-billion-dollar investment, is enormous. And they measure it, in minutes. So you have to be there. So the question is, how can you be there in advance if you don't know exactly when and where this equipment will fail? It's highly reliable, but it does fail. And so they have constructed fairly extensive networks, supply chain networks, which is illustrated here, in order to support this installed base in countries across the world. In order to do so, they have to make the resources required to support and maintain the equipment available, in particular what we call the spare parts. So the planning of inventory for spare parts across this multi-echelon, multi-level, multi-location network is the heart of the problem. And in managing this process, there's a trade-off between how much do you spend on inventory, what's your investment, and other perhaps direct costs, and your ability to respond quickly. As I mentioned, Intel has a standard for their suppliers of 15 minutes. In order to achieve that trade-off in a cost-effective way, at a low cost and high level of customer service, you have to manage this global network with a central distribution center, a variety of regional distribution centers, and many forward location depots that are used to support the installed base. Okay, so let me proceed. Yes. So we have had the opportunity to apply our methodology to this particular problem. And what's illustrated here in this graph is what's known as the efficient frontier. The horizontal axis is the fill rate. That's the likelihood or the probability that when a demand caused perhaps by a failure of equipment in the field should occur, what's the likelihood that the supplier of the equipment, the supporter of the system, has that part available off the shelf to fill the demand? That's called the fill rate. Obviously, you would like it to be 100%, but of course, in reality, it'll be less so. And in order to achieve that, you have to invest resources, in particular, invest in the inventory of parts. With more inventory, there's a higher fill rate, hence the efficient frontier. The notion of the efficient frontier is that's the optimal trade-off is achieved. Now, let me identify some other points in this graph. The purple point represents the performance that was achieved by this company that we've worked with by using a state-of-the-art inventory planning software solution. And that achieved something on the order of 77% fill rate and about 135 million in parts investment. The orange point represents a marked improvement over that in the sense that the investment is pretty much the same, but they've moved to the right. They now have a higher fill rate. How did they do that? This is where managers who have deep knowledge of their environment have overridden the recommended optimized solutions from their planning system based on their knowledge, based on their exposure to data that perhaps is not considered in the planning system. The green points, those are the points that were generated by the 83 global solution that we will be talking about. And you notice that they are down and to the right, which is where you want to be. And so this represents a true efficient frontier. And as we know, this can lead to either a 15% cost reduction or a 5% improvement in fill rate, or some combination of those two. Okay, I'll hand it over to Vinayak to talk about the second example.
Thank you, Morris. So our next case is from a manufacturer of an advanced consumer electronics product. The products are manufactured by contract manufacturers in Asia, then transported to our client at a central distribution center that is located in the United States. And then it is shipped through the network of distribution facilities that their customers have. Their customers are companies like Walmart, Best Buy, Amazon, and so on, many of these retailers. And eventually, through these retail outlets, the product gets sold to customers across thousands of retail stores and as well as online. A main challenge for this company was how to make sure that inventory is positioned correctly. And this was a real challenge because this company was at a shortage of products. And as a result of that, what ended up happening is that there were many stores which did not have inventory of the product, while at the same time, there was excess inventory on many of the stores where there wasn't much demand. So correctly positioning inventory to places where demand was a big challenge for this company. So the way this company operated in terms of their supply chain is how traditionally companies operate, which is they make forecasts and they use those forecasts to do their supply chain planning. A challenge for this company was that they have not one forecast, but many different forecasts. They make their own internal forecast, as well as their customers provide their own forecast. And because they had many customers, there were just too many forecasts flying around. And how do you take all of those numbers and use those for supply chain planning was a big challenge. A second challenge also was that a lot of times they run promotions, and how do you take that promotion information into account in supply chain planning was also a big challenge. So what we did for this client is that we gathered end-to-end supply chain data for this complex network. And our end-to-end data was able to represent the supply chain all the way from their manufacturing location in Asia down to the thousands of retail stores in the United States. And the data that we gathered included information such as sales history, seasonality factors, forecasts from their multiple stakeholders, as well as demand interventions such as price and promotions. A key challenge then is to how do you take this data and use that for supply chain planning? And what we were able to do is to run our machine learning or our AI model across this end-to-end supply chain to help them configure their supply chain in a better way. And one of the things that we did, for example, was to highlight the impact of the demand interventions on their sales. So if you look at this graph, the blue line in this graph is sales, while the red dots in this graph indicate the scale and duration of a variety of different promotions. And what the machine learning model was able to do is to correctly identify the causal impact of a variety of demand interventions, such as promotions on the sales lift. So for example, some promotions like Black Friday, Cyber Monday had a very large lift in sales. And our machine learning model was able to identify that causal lift and use that information to assign a larger weight on these promotions, which resulted them to start planning their supply chain to position the inventory correctly. Whereas some of these promotions, for example, promotions like Father's Day had much less impact. Not surprisingly, I guess, children don't care about dads as much. So the Father's Day had a much smaller lift in sales, as we see here in this graph. And the machine learning model was also able to identify that causal impact correctly. So a key point to note here is that machine learning models can help learn, or organizations learn, the impact of demand interventions, such as promotions, and use that for supply chain planning. One of the things that I want to highlight here is that our supply chain planning model that we generated was not a black box. A big criticism of AI and machine learning models is that AI models are often black box in nature and you don't know really what's driving. one of the things that we were able to do for our client is that we were able to provide visual pictures that help clients to kind of visualize what was driving the stocking recommendation. That is what is shown in this picture. So if you look at this picture, the height of this graph is the total stocking level that is being recommended by the AI model. And one thing that you'll notice that this height can be broken down into a variety of components that are depicted in different colors. So for example, the green bars represent how the company's forecast is driving the overall stocking recommendation for this company. So the key here is that while traditional AI ML models are black box in nature, they need not be, and that is what our approach has shown, is that you can actually use AI to understand what is driving the recommendations for the company. So I'm going to pass it back to Morris to discuss our third case study.
Okay, thank you, Vinayak. Let me just mention something that, this is the third example of a different industry. And I just want to emphasize that all of these examples were analyzed by our AD3 software, which was configured to represent the particular aspects of those supply chains. So the methodology is not only scalable, but flexible to capture different supply chain environments. So let's move to the grocery sector. This is a project that we actually worked on with LTP directly, and we obtained data from a multi-year training period for different product categories, particular canned food, kitchen, beer, and laundry care. Our approach was to use the digital twin and optimization capabilities of our underlying solution to come up with stocking level recommendations, which, as Vinay pointed out, are functions of the data inputs in terms of minimizing investment and meeting category level fill rate targets. The results that we achieve in terms of service level and average inventory are then computed for each of the simulations in order to compare the performance. And so what's illustrated here is another example of efficient frontiers, where the x-axis, the horizontal, is the fill rate as a percentage, and the vertical represents the investment in value of on-hand inventory for all of the graphs. And each of the different product categories is illustrated here. They were analyzed separately. And you can see that the green lines represents the solution from our underlying methodology, and the red lines represent the company's current policy. And again, the efficient frontier is down and to the right, which represents an improvement in terms of increasing customer service and decreasing inventory investment. Okay, so let's move to the next section of how do we actually do this? And I'll turn it back to Vinayak, who'll give us a deeper dive into the underlying methodology that we've alluded to. Vinayak, take it away.
Thank you, Morris. So what I'm going to do next is to talk a little bit about how do we do this. So at this point, you may be wondering how were we able to achieve the solution that we just talked about. And I'm going to kind of dive in a little bit deeper to give you kind of an understanding of what we have built. And we call our approach as optimal machine learning. And we've written about this approach in a variety of different articles. So if you're interested in learning more about how does this approach works, we would highly recommend that you take a look at an article that we published in the Harvard Business Review earlier this year. And what we have created is a software solution that implements the machine learning methodology on a cloud that provides a fast, low-cost solution for supply chain planning. So what I'm going to do next is to just go a little bit deeper to understand how does this actually work. So if you think about traditional supply chain planning can be described as a 4 or 5 step process. This begins with taking historical data and feeding that to some forecast algorithm. The forecast then gets fed into a business model that looks at the objective of the company. It may be profit maximization or cost minimization. And then that business model incorporates all of the practical constraints that the companies or the supply chain might have. And an algorithm kind of evaluates a variety of different potential solutions And based on that, supply chain decisions such as inventory or capacity may be outputted by the approach. And that's a very traditional approach. And one of the reasons why this approach we think is not really going to work in the future, as Pedro had talked about, is because forecast errors are really high in practice. So as the world becomes more unpredictable, an approach that completely relies on forecast accuracy is likely to fail. And what we have done is come up with an approach that kind of bypasses the need for forecast accuracy, as is illustrated in this picture over here. So the way our approach works is that we take in all of the data that is available in the supply chain, the end-to-end supply chain data, and we say, well, what's the connection between the real world data and the decision? Can we just go directly from the data into the decisions by using a machine learning approach? And that is what we call as our supply chain genie, that is powered by the optimal machine learning approach. What our machine learning model does is that it looks at all of the data and then looks at the historical relationship between that data and the decision and says, well, what's the optimal relationship between the data that we have and the decisions such as inventory or capacity that we are planning to make? And the machine learning model is able to learn that relationship, and it assigns weights to the data. And based on that, it is able to construct a decision function, or what you would call as a decision rule, that takes in data, and based on that comes up with a recommendation for the optimal supply chain decision. So key to note here is that our approach does not rely on forecast accuracy. It can use forecast as an input, but it does not really require accurate forecast to come up with good decisions. So our approach is fundamentally based on what we describe as a three-layered pyramid that is depicted in this picture. The base of this pyramid consists of a data architecture that enables fast solution to complex supply chain networks, which I'll describe in more detail later. The middle layer consists of a digital twin that allows the impact of any supply chain decision to be measured at a very granular level. And the top layer of this pyramid is an optimal machine learning model that allows supply chain decisions to be optimized for achieving objectives such as minimizing cost or maximizing service while obeying business constraints such as budgets and supply resources. So if you look at why do we have this three-layered approach, the reason why we have end-to-end supply chain data structure is that we believe that traditional data architectures are ill-suited for applying machine learning for supply chain planning. So as a result, we have developed a proprietary graph network-based data architecture for applying optimized machine learning to supply chain planning. This provides benefits such as blazing fast access to end-to-end supply chain data, improved visibility in the supply chain, and integration across a variety of platforms currently used for supply chain planning. The second layer of our pyramid consists of a digital twin. And while there's been a lot of talk about digital twins for supply chain planning, we believe that current digital twins fall short of realizing the full potential of AI and machine learning for driving resilience in supply chain. So the digital twin that we have built is not just simply a snapshot of supply chain data, but it is a granular and dynamic representation of the supply chain based on transactional records. And this allows accurate computation of a variety of different KPIs for a lot of what-if type of scenarios. So as Maurice had mentioned earlier, while we can't predict the future, we can imagine a future. So what the digital twin allows managers to do is to imagine a future, but because this is a granular digital representation of the entire supply chain, one can run through that future and pinpoint what the impact of that future would be. So for example, what if the ship gets stuck in the Suez Canal? What would be its impact on my retail store in San Francisco? We can answer such questions because of the granularity of this digital twin that we have built. So as a result, managers can redo past. They can ask questions like, well, what if I had done something differently in the past? How would that have worked out? Or they can imagine a variety of different scenarios and look at whether their supply chain is robust, or if they're thinking about different supply chain architecture. So for example, if managers thinking about moving supply chain locations to different countries. How does that manifest itself into performance and KPIs? The digital twin allows managers to answer questions like that. And finally, what we have is at the top of the pyramid, we have a machine learning framework that allows decisions to be optimized. So given a variety of different criteria that managers may have, such as profits and cost, those can be optimized using a machine learning model that we have built. And the key to note here is that this model is flexible enough so that it can be configured to a variety of supply chain structures that are seen in practice. As we had talked about in the earlier section, we had applied it to semiconductor industry, to the electronics products supply chain, as well as the grocery sector. So a variety of industries can learn from this approach that we have built. So if you think about the supply chain genie that we have built, the way it works is that the goal is to make decisions. And the way the model works is that it has created a decision rule based on the machine learning algorithm that has been created. And then the supply chain is kind of structured using the data structure that we have. And then we use the machine learning model to train and learn based on the data to create this decision rule. And based on the decision rule, as well as observations about future and scenarios that are imagined, it recommends decisions. Those decisions are fed back to the digital twin that we have built, which provides a feedback loop to adjust the machine learning model. So what essentially we have done is created a continuous improvement cycle that the machine learning model keeps learning and becomes better and better the more data that he has. So this kind of describes the overall approach that we have used. And I'm going to hand it back to Pedro so that we can answer any questions that you may have about this approach of using machine learning and AI for supply chain planning.
Okay, this is great. Thank you for holding on all this time with us. This is great that we got it so far, and we have a lot of questions actually from the audience. So I'll go through the different questions that we have here. I'm sorry for maybe not being able to cover all of them, but I guess we'll be most likely able to go through all of them. So great. So one question that one of the participants was wondering, Morris and Vinayak, is, so we saw examples from the let's say the semiconductor industry, we saw examples from retail, we saw examples from consumer electronics, I guess. Is this approach to supply chain planning something that you can, is this something that we can use across all different industries? Are industries more prone to this than others? What are the main drivers to make the supply chain, the go-to approach for supply chain planning?
Okay, I'll take a crack at that. Thank you, Pedro. As we mentioned, the underlying methodology is driven by our model representation of the supply chain, which is a very detailed supply chain network model that's driven by detailed transaction level data as well as all kinds of other data. And so as long as there's data, and most companies have access to data in making these decisions, our methodology can be applied. We have focused on industries that you've seen, which consist of assembly of products. That's the most common one, but it could be extended to other types of industries. So any manufacturing industry, I would argue, is a good candidate for what we're talking about today.
Super. Vinayak, you want to add something?
Yeah, one thing that I would like to add is that as long as you know the structure of the supply chain, and if we can capture that, we can use this approach, right? So as long as you know who your suppliers are, who your customers are, we can build a representation of that supply chain, and that can be captured. And of course, having data related to both demand and supply. Right? Those are the two essential things that are needed to apply this.
This seems like very fair minimum requirements to know who your
Let me
clients
just add one comment here. As was mentioned earlier, we avoid what's called the black box syndrome. And so in working with companies, we start with the domain experts, the managers of the supply chain function. And we ask them, what are the key problems that you have? And what are the data that you're looking at beyond the data that is, generally produced by the existing planning, ERP, and PLM systems that every company is using, but there's other data, the management tracker. So as long as that data can be accessed, then we can figure out the best way to use that data. So there's no limitation on the information that we can use. And as Vinayak said, as long as there's a deep understanding of the supply chain, then we can work together to configure this underlying methodology to capture the key trade-offs and constraints of the environment.
Great. Let me ask you a follow-up question that we have here, and I think it's maybe bothering a lot of the participants or maybe in the minds of the participants of the webinar, which is so there's a big. So I'll try to rephrase it a bit, but I think the main idea is there's a bit of we have been doing supply chain planning like this forever, right? So we do a forecast, there's a sales and operation, with this process, maybe more or less optimized, maybe more heuristically less optimized. But this two-stage of forecast and then, doing our planning, this has been there for ages, right? I see that, and I think we all see that as an opportunity, right? And the supply chain genie, the idea is that let's take this as an opportunity, and maybe why do we really have to do this two-stage approach? Let's just use forecast as yet another input that can help us actually to crack down what we really want, which is to take the best supply chain planning decisions, right? But there is a downside to this, which is change management. It's a barrier to adoption. People and supply chain managers, I wouldn't say that they are the most versatile people ever. They may feel like, I've been doing this forever. Now we have the supply chain genie that leverages AI to really redraw and redesign this process. How do you feel like this may be a barrier, the change of the process while adopting the supply chain genie that we just described over here?
So I'll take a quick cut at that, and maybe Vinay can add to it. That's a key question. And whenever you try to change a system as complex as supply chains, there's always going to be resistance to change. However, what we have found in working with companies, and Vinayak and I have been working on supply chains with companies for many years, is we have to bring in the knowledge of the managers as to what are the key issues. The data scientists and the computer and the IT folks says, where is the information? How do we get access to it? And we have to, and I should mention that we're working in partnership now with LTP, who has extensive experience in implementing supply chain planning solutions. And we've already worked together on projects. And so we're bringing a team that consists of experts in how to formulate a model. And that's the key question. It's not, I've often told my students, it's not what you put into a model, it's what you leave out of a model. That's the real knowledge. And so how do you formulate the right level of detail and the right level of understanding? And in order to do that, we bring together a team of the experts from the company that know the environment and know the data, and we bring together people that know how to implement these systems, as well as those of us in 83 who can help configure the system optimally to your environment. I don't know, Vinayak, if you want to add to that.
Sure. And talking a little bit more about the process itself, Pedro, your question was like, hey, we're going from this traditional approach.
Not my question, the audience question.
Yeah, the audience's question, which is we have this two-step process of we have forecast, and then we use that, feed that to some algorithm, which gives us supply chain decisions. And what do we mean by we just bypass that forecasting step, right? And that is requires a cultural change in the organization to understand that, hey, at the end of the day, what we are really interested in, forecasting by itself is never the end goal.
Yeah.
It's always a means towards an end. And what we really are trying to do is we'll take forecast as an input. If you have forecast, we'll take that as an input, but let the machine learning model figure out how important that forecast is for the decision that we are trying to make. And if that forecast does have a lot of information in it, the model will assign a high weight to that decision that we are trying to make. But if oftentimes the forecasts are bloated because of different biases, customers, for example, trying to get hold of inventory may try to inflate that forecast. The nice thing about the machine learning model is to learn that, and it will deflate the forecast, right? So really what the model does is that we need to kind of understand that forecast accuracy is not the key. And I see some questions over here which are asking about what is the accuracy of our forecast. Well, we do not generate forecasts, which can be a shock. What you really are worried about is how do you make good decisions. Forecast accuracy is not the key metric that one should be looking at when we make supply chain planning.
That's a great segue, Vinayak. For actually, we have here two questions, one from the packaging industry, I understand from our guest, and one from the mining industry. And both of them, basically, they are worried about, what are really the KPIs that we are looking for here, right? And you said that that's not forecast accuracy. In our examples, we discussed cost and service level. Are there other KPIs that we should be looking at on these AI-driven supply chain solutions? And one question here is from one of the supply chain manager from the mining industry. He's saying, when we have gone through these projects, how did the results match the expectations of, the clients that were, using this? We do a quick round on this, and then we still have a few more questions. I'll please try to go over one more. Let's go.
I'll take a quick shot at that, and then let Vinayak respond. In terms of KPIs, one of the advantages of our approach, which is we have this detailed digital twin, which really is a representation of the dynamics of the supply chain, allows us to measure on a transaction level all of the metrics that normally would be used in controlling and managing the supply chain. And so beyond the traditional cost and customer service metrics which we produce, we can generate metrics associated with the global reach, with the agility of the system, how long does it take to recover, things of that sort. And the real effort, in our experience, is working together with the customer in reviewing the data to understand what data goes in, and then reviewing these KPI outputs to understand what are we actually looking at. And that's where we spend, I would say, most of the time in working with customers. And that can be adapted, as you noted, to different industries.
Have we ever faced a limitation in terms of, so that connects to a follow-up question that we have here, like a limitation on, we cannot really use the supply chain Genie and our machine learning approach because there was not enough data. Do we really have any?
Yes, that's a question that always comes up. We say more data is better, but you don't have all the data. The key is to make the best use of the data that you do have. And, this one example that we looked at, which was the grocery industry, we had very limited data. It was just basically historical records. In the semiconductor equipment, one of the key breakthroughs was to add just one data variable that was not being used, which was the number of installed base equipment, the population, as that changed over time. And that was ignored in the planning system.
So it's not so much the size, but really, testing different sources and really,
figuring out what's really important. And that's what the machine learning algorithm does for you. That's the key.
Great. So let me go into that segue, because we have another question that really types that, which can we shed some more light on what kind of really what machine learning model is this? What is it doing, basically? Vinayak, maybe you want to take a step.
I'll let you respond, Vinayak.
Yes. So essentially what the machine learning model does is looks at the historical data. And historically, we may have observations on things like demand, promotions, prices, and things on. And what it does is basically looks at the entire supply chain network, and for whatever objective you have, like what is maybe it's cost minimization, maybe it's profit maximization. It says, well, what's the weight that I should attach on an input like, say, historical demand or forecast or promotions, and uses that weight to essentially compute the recommendation on supply chain decisions like inventory or capacity and things. That, in a nutshell, is what the machine learning model is doing, is taking in data and figure out which ones are important, which ones are not, and how much weight should we be assigning to all of the data inputs that we have.
Super. Vinayak, Morris, I think this was very insightful. Thank you both for all these explanations and for, delivering such an insightful talk. And I'll just now wrap up with you guys. So, for everyone that is listening to us, this was a great pleasure. Thank you so much. I guess it was clear that it's not just about the data, it's not just about the machine learning model, it's not just about the digital twin, so the representation of the supply chain, but it's actually how do we put all these three elements together to really change the way we have been doing supply chain planning. And I guess, that you have all seen that, it's been such a while that we have been using this traditional approach. And the promise of the supply chain Genie is really to turn this around and to leverage this technology that we have now at our disposal to better supply chain planning. But as most of you have kind of hinted through your questions, this is not a technology push type of initiative. The idea is that we really can see different results on your supply chain indicators, being it more service level, being it more, cost indicators. So whatever lens you want to look at to understand your supply chain, probably more than one lens, this is an interesting approach that you might want to know more about it. And for you to know more about it, of course, feel free to drop us a line. Here you have my email and also the email of Maurice. And we also have added here a QR code to a homepage that we have built on purpose to explain a little bit better what Supply Chain Genie is all about. Once again, great that you have joined. I hope you enjoyed and talk to you soon. Thank you.